Electricity is so much a part of everyday life that it's easy to forget that it can also be dangerous. It lights our homes, runs our computers, smartphones, toaster ovens, and refrigerators, as well as powers the equipment and machinery that we use in our jobs. But electricity causes thousands of injuries and hundreds of fatalities every year, and those numbers are increasing. In addition to harming people, electrical energy can start fires and cause explosions that may result in extensive and costly damage. In this program, we will take a close look at how you can work safely with electricity. We'll discuss how electricity works, its hazards, and the procedures and equipment you should use to avoid them. To work safely around electricity, it's important to understand how it works itself. To do that, we need to become familiar with a few terms: current, volts, amperes, and watts. Current is the flow of electricity, for example, in a wire. The amount of current that is flowing is measured in amperes, or amps for short. Most household and industrial electric wiring carries 15 to 20 amps. It's the current that gives you an electric shock, and it doesn't take much current to hurt or even cause a serious injury. In fact, the amount of electrical current that's needed to light up a holiday bulb can be fatal if it passes through a person's heart. Volts are another term we hear a lot when we're talking about electricity. It describes the amount of force behind the flow of current. In North America, most power tools and household appliances run on 120-volt current. But some specialized and heavy-duty equipment that you may encounter on the job can require 220 volts or more. The next term, watts, describes how much energy a piece of electrical equipment uses when it's operating. An incandescent nightlight burns about 5 watts of electricity. A 3-foot ceiling fan running on high uses about 50. A small window air conditioner draws about 500 watts. And an electric clothes dryer uses close to 5,000. When you divide the number of watts by the voltage of the wiring system, the result is the equipment's power usage in amps. For example, a 500-watt air conditioner running on a 120-volt electrical system draws about 4 amps of current, whereas a 120-watt light bulb only uses a single amp. Running a 1200-watt hair dryer draws 10 amps, and as many of us know, that is sometimes enough to dim the lights when you turn the dryer on. To harness the power of electrical energy, we take advantage of the fact that electricity naturally flows in a loop called a circuit. A circuit begins at the power source, continues through wires and electrical equipment, and then returns to the source. In order for power to flow so that electrical equipment can run, the circuit has to be complete, that is, with no interruptions. As you might suspect, an on-off switch works by making and breaking the electrical circuit. When the switch is on, the circuit is complete, electricity flows, and the equipment runs. Moving the switch to the off position breaks the circuit, which stops the flow of electricity and the equipment. So how do electrical outlets work? You could think of an outlet as half a circuit that's waiting to be completed. When you plug in an electrical device, you're attaching the rest of the circuit, which we complete when we turn the power switch on. But you have to be careful. Plugging in too many pieces of equipment or connecting devices that draw too much power can overload the receptacle and the wiring that supplies it with power. An overload condition can cause the wiring to get hot enough to damage the equipment and possibly start a fire. The circuit breakers and fuses that are built into electrical systems have been designed to prevent this. If equipment tries to pull too much electricity through the wiring, these safety devices automatically break the circuit to stop the flow of energy. A device called a ground fault circuit interrupter, or GFCI, performs a similar function within the electric outlet itself. If the GFCI senses a dramatic change in the flow of current through the receptacle, such as when a cracked power cord starts leaking power to the ground, it breaks the circuit. One of the most important things to understand about electricity is that it will always try to find the shortest and easiest way to get back to the beginning of the circuit or to the earth itself, whichever it can find first. This return path is called ground, and if that path leads the electricity through you, you're in for a nasty shock or worse. One way to prevent this from happening is to build a safe return path into electrical devices so that the grounding is controlled. Equipment that has this controlled grounding feature is called grounded equipment. Grounded equipment will have a 3-prong plug on the power cord. The round connector on the plug is the ground prong. It connects to ground through the outlet so that any stray electricity can be channeled safely out of the equipment. But for this to occur, the outlet itself must also be grounded with an electrical connection to the earth. Don't assume that an electric outlet has this connection just because it can accept a 3-prong plug. The only way to be certain that an outlet is grounded is to test it. Like the sign says, electricity can be dangerous. In addition to thousands of injuries, electricity is involved in more than 300 workplace fatalities each year. To stay safe, you need to be able to recognize potential electrical hazards and know how to avoid them. Start by always inspecting power cords and extension cords for wear and damage before you plug them in. Look for worn or cracked insulation, exposed or fraying wires, and other defects. If you find problems, take the cords out of service immediately, then have them repaired or replaced. Watch out for overloaded outlets as well. Plugging too many cords into a single outlet can damage the wiring it is attached to or even start a fire. You can prevent an overload by plugging some of the equipment into other outlets that are on different circuits. While extension cords can be convenient, they can create problems as well. Remember that they are safe only for temporary setups. They're not designed to be used as permanent power supply solutions. To prevent overloading a cord, be sure to choose one that's rated to handle the amount of electricity you're going to be using. And all electrical equipment should be properly grounded. So watch out for adapters that are being used to connect 3-prong plugs into 2-prong outlets. If the adapter's ground wire isn't connected to a grounding source, it's a dangerous setup. Another bad idea is trying to make 3-prong plugs more versatile by removing the ground prong. If you find plugs that have been altered this way, take them out of service and have them repaired or replaced. But you shouldn't try to repair any electrical problem yourself unless you're qualified to do so. Winging it could endanger both you and your coworkers. Instead, advise your supervisor so a qualified repair person can handle it. Before a qualified electrician services or repairs electrically powered equipment, they will disconnect all power sources and then follow proper lockout-tagout procedures to ensure the power is not turned back on by mistake. If you encounter equipment in your workplace that has been locked and tagged by someone else, do not try to restore power. Never remove locks or tags unless you are authorized to do so and you install them yourself. Your last line of defense when you're working around electricity is personal protective equipment, such as insulated gloves and rubber-soled shoes. What you should wear can vary significantly from job to job. To find out what PPE is right for you, talk to your supervisor. Some work environments create special electrical hazards, and it's important for you to know about these situations so you can take appropriate safety precautions. The first thing to remember is that water conducts electricity. Using electrical equipment in the rain or areas that are wet creates very serious shock hazards. Even double insulated tools can give you a shock if water gets inside them. So OSHA recommends not using electrical tools in damp conditions at all, unless the tool is connected to a ground fault circuit interrupter GFCI. You should keep power and extension cords out of puddles as well. It's also a good idea to wear shoes with non-conductive soles. Make sure your hands are dry before you plug anything in too. And never plug in extension cords or electrical equipment that has gotten wet. High voltage power lines also create special hazards. If possible, the lines should be de-energized before you begin working near them. When that's not possible, it's crucial to stay a safe distance away. Keep yourself and any conductive object that you're holding at least 10 feet away from any power line that's carrying up to 50,000 volts. If the voltage is higher, you should stay even further away. It's critical to remember that you must also maintain these distances if you're driving a vehicle or operating equipment such as a forklift or a boom crane. If they get too close to a live wire, the electricity can try to go to ground through them and you. Metal ladders can also create problems, no matter what the voltage is. Never use a metal ladder when you're working near power lines, electrical wiring, or energized machine parts. The metal will conduct stray electricity straight to your body. Use a non-conductive fiberglass or wooden ladder instead. Sparks are something else you need to watch out for. Since electric tools and machinery can create sparks when they're operating, they can cause problems in work areas that contain flammable materials, since a stray spark could easily ignite them. If there could be flammable gases or vapors in an area you want to work in, stop. Don't turn electrical equipment on or off. It could cause a fire or even an explosion. Make sure the atmosphere has cleared before you touch a switch. When you're working around high-energy electrical systems, it's also important to understand the potential for arc flash. An arc flash is essentially an electrical explosion that creates enough heat, light, noise, and power to injure or kill anyone unlucky enough to be near it. There are several things that can cause an arc flash. Accidentally dropping a metal tool into high-voltage equipment can create one. So can digging or cutting into a power line. Shorting out a high-voltage electrical panel can cause an arc flash too. Fortunately, most arc flash hazards are clearly labeled, so pay attention. And talk to your supervisor before starting any work near a potential arc flash environment. Sometimes, despite our best efforts, things still go wrong. If an electrical accident occurs in your workplace, it's important for you to know what to do, as well as what not to do. For example, if a coworker is being shocked by a live electrical source, do not touch them. That will expose you to the same electrical charge that they are receiving. Instead, cut the power. This might require pulling out a plug or throwing a switch or a breaker. Do whatever is necessary to turn the electricity off, then assist the victim. An electrical fire can result from a short circuit, sparks, or overloaded wiring. You can try to put these fires out with a fire extinguisher, but only if you've been trained to do it. However, you can't use an extinguisher that contains water because water conducts electricity. Wetting down an electrical fire could get somebody killed. In these situations, you need to use a Class C extinguisher. They contain non-conductive fire retardants and can put out electrical fires safely. You can find an extinguisher's letter code displayed on its label. Different types of electrical accidents can result in different degrees of injuries, ranging from minor to severe, even life-threatening. So having a working knowledge of first aid can literally be a lifesaver. Since even minor burns can be very painful, hold them under cool running water to lessen the discomfort. You can then apply moisturizing cream, aloe vera gel, or a burn treatment product. If a blister has formed, try not to break it. More serious wounds, such as those caused by an arc flash, will require medical attention. Call 911 for burns with large blistered areas or charring, wounds that are deep or have gaping or jagged edges, or spurting blood and bleeding that will not stop. The 911 dispatcher may also be able to advise you on how to care for the victim until the EMTs arrive. We all know that electric shock can be used to jumpstart a person's heart, but it can also cause a heart to stop beating. If a victim of an electrical accident stops responding to you or stops breathing, they may be going into cardiac arrest. In this situation, you should have someone call 911, begin CPR immediately, or use an AED, automated external defibrillator, if one is available and you know how to administer it. Just remember, the best way to deal with electrical accidents and the problems they can cause is to prevent them from happening in the first place. As we've seen, electricity can be a good source of power, but to work with it safely, we need to take some precautions. Let's review. Understanding how electricity works can help us to avoid its hazards. Always inspect electrical equipment for wear and damage before using it, and make sure that it's properly grounded. If you find problems with extension cords or electrical tools or equipment, don't use it. Have it repaired or replaced. Be sure to follow safe practices and wear appropriate PPE when working around electrical equipment. Learn to recognize these special hazards like arc flash that are associated with using electricity in certain environments. Electricity can be hazardous, but now that you understand how it works and the safe practices you should use to avoid those hazards, you can help ensure that you go home injury-free at the end of every day.